Hello everyone, I'm Rohan Singh. I'm an Android developer and welcome to Kotlin Mumbai. So I hope everyone is enjoying a great weekend ahead. To make this even more great, we are having this session. Before starting, let us introduce who we are. So we are open community for developers. We love all stuff related to Kotlin and other things, but our main focus is on Kotlin and Android related things. So for more information, you can visit our website, kotlinmumbai.org, which is our official website for this community. Also, you can also tune into our Twitter handle, where you can get latest updates about Kotlin related stuffs and all other things. It is at the rate Kotlin Mumbai. You can also see many tips and tricks, and there are many beautiful things over there. Like I have seen some of the great tweets over there to like lambda functions and all other stuff. Like Siddesh put something, Shreyas put something, Rishabh put something. So that's a little introduction of our Kotlin Mumbai. To let us know more about the code of conduct for this meeting, I will hand it over to you, Chetan.
Thanks, Rohan. And hello, everyone. Hope you guys are excited for today's talk. Before we get started, I will just take a moment to share our code of conduct, which is quite important and literally the straightforward. So the thing is, we just here to enjoy the talk and let others enjoy it as well. We as engineers are very curious people and we hold strong opinion about things. So if you feel there is a disconnect between your opinion and what we are presenting here, kindly drop it into the comment section, but please don't interrupt the session. Also, it is important that you don't fight within the comment section with each other. Harassing people based on gender, race, religion, XYZ factors won't be tolerated. Give respect and take respect is the motto. Respect everyone else's opinion. And lastly, success of this event rely on you to be a good listener. So relax, observe all the detail our speaker is here to present. And if you have some question, write it down in the comments or use Slido. Do visit our website kotlinmumbai.org to know more about our code of conduct. Thank you, and to you, Shreyas.
Yeah, thanks, Chetan. Hey everyone, let me introduce amazing speaker of today's session, who is Sagar, and I hope everyone knows
Yes.
him already. Yeah, so Sagar Viradiya is a Google developer expert for Android, and currently he's working at BookMyShow as a lead Android engineer. And he's a coffee lover and open source enthusiast, and he loves to give back to the community by blogging, speaking, mentoring, and contributing to open source projects. So that's little introduction about Sagar. So I will hand over this to Rishit.
Uh, Before we start this session, I just wanted to talk a little bit about how we are going to take any questions that you all have while the session or after the talk if you have any questions. So you can go to slido.com. You'll not require any kind of login and enter the code KUGNUM and ask any question you have on Slido itself. We'll relay them over to Sagar after his talk ends, or you can also scan this QR code, and one of us will also put a direct link to our Slido in the chat section, so you can also just go ahead and ask any questions you might have. And before I give it on to Sagar, I would just like to tell you all that this event is also being recorded. We'll put it on YouTube, so uh, just be aware of that. And with that, I hand it over to Sagar. Or maybe Sagar, you can start sharing your screen.
Sure. Thank you so much, guys, for joining today. So I'll be speaking on, Coil, modern image loading library on Android. So the idea of this talk came into my mind when, I was contributing to Coil. So I was going through the library, and I had to learn everything. So I thought it would be a good idea to, give talk on this. Um, if you are into open source, perhaps this talk will help you to understand this library, and uh, you can quickly start with uh, going through library. And if you're planning to contribute by the end of this talk, I think you'll have an idea about this library. So this can help you to start with open source contribution. However, if you are not into open source, understanding library is always better, right? I mean, whatever you are using, at least you should know the basic things about library. So this talk will give you details about internals and in general, like how to use this library. So, before I start, just let me give you a little intro about myself. Uh, I think Shreyas covered everything. My name is Sagar. I work at BookMyShow. I'm also part of this community called GDG Mad. And on the bottom right corner, you can see our Twitter handle at the GDG Mad. You can follow us. We are monthly meetup based in Mumbai. We cover, design, tech, soft skills, everything. And you can also check our website, ggmad.com, for all details. I'm active on Twitter, so if you have any question after this session, you can hit me on Twitter. This is my Twitter handle on bottom left corner. So with that, let's get started. So agenda for this talk is, we'll first see what is coil and why you should use coil, why you should consider coil. And then we'll see like how you can utilize, concise API that it offers if you're a Kotlin user. And if you're a Java user, you can also use this library. And then we'll, go into detail about image loading pipeline of this library, and then we'll touch upon, the in-memory caching. So what is coil? So coil is an acronym for coroutine image loader, and you must have guessed like it has support for coroutine. Under the hood, it uses coroutines, and also it gives you a nice API that you can use to load image within coroutine context. And you may be wondering, like, because there are a couple of libraries out there, Glide is there, Picasso is there, Fresco is there. Then why we need another library for Android? So, like, if you have a really huge code base and if you are using one of this library, and if these libraries are like solving your purpose, and if you feel like this library is perfect for you, don't think about switching to coil. However, like this, if you are a Kotlin user and if you're planning to use Kotlin in your code base, and Kotlin is future, like at least when it comes to Android development, you might need to consider all the benefits this library offers as a Kotlin user. So, and also library have very nice documentation on the migration guide. So if you're using one of these library, Glide or Picasso, you can easily do migration to this library, Coil. So why Coil? Why you should consider this library? So it's a modern library. So under the hood, it uses OKHTTP, it uses OKIO, it uses lifecycle component of Jetpack. So this way, and also it has support for Kotlin Coroutine. So this way, it's a modern library. It gives you all the modern tool that you need for image loading. And it's easy to use. So it has very nice API for Kotlin, very clean and concise API. If you're a Java user, you can also use this library I think for Java user also, this API is super simple. And it's lightweight, lightweight in the sense like coil adds around 2000 methods. So compared to and 2000 method if you're already depending on OKHTTP and coroutine. So if you compare that with Picasso, which is very minimal library, it doesn't give you a lot of functionality. Compared to that, it's like so Picasso also adds around 2000 method, but the fact that this library gives you so many features, it's a good library, I would say, with less memory footprint. And this library is like very lightweight compared to Glide and Glide and Fresco. So those are heavy libraries, but this library gives you like almost all functionality that Fresco and Glide offers you. and it's very fast. So Coil performs, Coil has its own caching layer, and it performs, downsampling of your image if you're on the low bandwidth. And also it performs, cancellation of request automatically. So you don't have to worry about canceling your image request and everything. So it's very fast in that sense. So let's look into, the API, how you can consume this library. So the very first thing that you will be needing is ImageRequest. ImageRequest is nothing but, object that you will encapsulate all the details about the image that you are trying to load. So it has a data, which is nothing but image source that you want to pass. Then if you want, crossfade or any sorts of animation, you can do that. And finally, you have to provide target and call the build, and it'll give you the image request object. And the next thing you will require is ImageLoader, instance of ImageLoader. Now, library already gives you, has implementation for ImageLoader, which is singleton. So, and it's recommended to use singleton because ImageLoader is a heavy object and it is responsible for, allocating the memory for in-memory cache and fetchers and decoders that we'll be, seeing in upcoming slides. But it is important to keep in mind, like, this should be singleton if you are managing by your own. And when you need your own image loader, basically if you are giving your own custom fetcher or maybe your own custom decoder, that time you will be needing to manage your own image loader. But by default, if you are not doing any heavy customization, you can depend on the singleton that library provides, and its extension on context. So if you're using Kotlin, then you can directly call context.imageLoader, and it will give you the image loader. If you're using Java, then you have to call coil.imageLoader, and you have to pass in the context. So as you can see in the second example, we are creating our own image loader, and we are customizing, available memory percentage. So this is nothing but, the percentage of your free memory that library will use for, caching. So if you want to customize things like this, then you have to manage your own image loader. And finally, you can call, ImageLoader.enqueue and pass in the image request, and that will give you disposable. Now, disposable is something that you can use if you manually want to cancel. A library will handle this for you automatically. But in case if you want manual control, that is also possible. And if you're a Kotlin user, it's super simple. Like so far, what we have seen is like you can use, image loader, and you can create image requests and use image loader to load image. But if you're a Kotlin user, this is the only thing that you need. So basically, library provides extension on top of ImageView. So you just have to call ImageView.load and pass in your image source. So the first one is fetching image from the URL, and there are many supported source. So you can pass the resources as well. You can pass the file object. You can pass the content URI. And if you want to customize few things, let's say if you need crossfade or transformation, you can do that easily by passing the trailing lambda. And this is nothing but lambda with receiver on image request that we saw previously. So this extension, the load extension, will take care of creating the image request for you, and getting the image loader and all the ceremony that we saw previously. If you're a Java user, you have to manually do it. But if you're a Kotlin user, this is what you have to do. Like, this is very clean and concise API. And it has support for coroutines as well. So if you want to load image synchronously, imperative style, you can do that. So notice, like, the image request that we are creating, there's no target here, because we are not loading image to our target asynchronously. Here, what we are doing, instead of calling enqueue on the image loader, we are calling execute. And execute is nothing but suspending function. So it will suspend your coroutine. And once the result is ready, it will just simply resume your coroutine again. And you can utilize your result. So coming to pipeline, this is how it looks like. So as you can see, like various stages are there. So let's just see, like, let's just go over them at high level, and then we'll see each and every step in detail. So the first thing that we already discussed, like you as a user, you have to pass the image request to the image loader. And then ImageLoader will be responsible for kickstarting your entire pipeline. So it will hand over things to interceptors, and the interceptor is nothing but similar to OKHTTP interceptor. And library took inspiration from OKHTTP interceptor, just how you intercept the network request. Similarly, here you are intercepting the image request. So it's the same concept. And then so you can wrap your own custom logic. Let's say if you want to short circuit the entire image loading pipeline, if you want to retry, or maybe if you want to add your own caching layer, you can do that. Then it will hand over things to mappers, and mappers allows you to map your own custom objects to the image source. So if you have your own custom object, let's say employee, and within employee you have an image URL of each profile URL of each employee. Instead of passing employee.url, you can directly pass the employee, and you can tell library how to map employee object to the image source. In this case, it's URL. And then it will hand over, after mapping your image source, it will hand over things to fetcher. Now fetcher is responsible for actually fetching your image from the source that you provide. So if you provide file URL, file object, it will fetch from your file system. If you provide HTTP URL, it will fetch image from the network. And if you give the local resource, your drawable, it will just give you that drawable. So basically, what it does, it converts. So in case if your source is not the local resources, not if your source is not drawable within your app, it converts your image data to buffer source. And think of buffer source as intermediate representation of your image that will be processed by decoder, and decoder converts that buffer source into actual drawable. So yeah, so decoder will decode your image, and once the result is ready, once the drawable is ready, it will pass in that to transformation. So transformation is nothing but if you want to modify pixel data. So let's say if you want to apply image filter, or maybe like apply circle crop transformation, or rounded corner transformation. So you can easily do that. Library has some built-in transformation, but in case if you need your own custom transformation, that is also possible. And finally, it will spit out image result, which is nothing but sealed class. And there could be two possibility. It could return, a success result, or it could return error result. If there's something wrong while executing pipeline, it will just simply return error result. So let's just see them in detail. So let's start with image request. So it's a value object that provides all the necessary information to your image loader. So as I mentioned earlier, like this object is responsible for holding all the details about how you want to load your image. So things like crossfade. Do you need any animation, or do you need any transformation? And of course, your data source from where you want to fetch your image. So you create it via a builder pattern if you're using Java, but if you're using Kotlin, it's super simple, as we saw earlier. And you can call, then after that, you can pass in that to ImageLoader. So the loader is nothing but a service class responsible for executing your entire pipeline. So this is the class which will kickstart the entire pipeline. So the moment it receives your image request, it will basically kickstart your pipeline and forward this to the next step, which is interceptor. And as we already discussed, like Coil provides a singleton instance of this image loader, and it's a recommended to use singleton rather than managing your own if you're not doing any customization. So keep that in mind. That is really important. And this is how, like, once you have the image request, basically what you do, either you call enqueue in case if you want to asynchronously load image to your target. And if you want to, synchronously execute requests, you call execute. And notice here, like in the image request, we don't have target here. So you just get the result and then basically act on it however you want. And yeah, so the next thing that will be executed is interceptors. So interceptors are nothing but the objects that allows you to observe, transform, short circuit, or retry requests. So think of it as like the chance for you to wrap your own logic inside the pipeline. So you can wrap your own logic, and that will get executed before pipeline starts. And it's inspired by OK HTTP interceptor, just how you intercept your network requests using OK HTTP. It's a similar concept. So to give you an example, here we have the custom cache interceptor, which is nothing but our own custom layer, custom cache layer. And you need to implement this interface interceptor and override intercept method. Now here in the constructor parameter, we are taking our cache, LRU cache. And first we are checking whether the request that will be executed, the bitmap is already there in the cache or not. If it is there in the cache, you just short circuit the entire pipeline. You just return success result, and library won't execute the entire pipeline. So it will stop here itself. And if it is not there, it will just proceed and it will execute the remaining steps. And if you want to plug in, so remember I told you like you need to manage your own image loader as a singleton if you want to customize stuff. So in this case, if you want to add an interceptor, which is nothing but your own custom cache layer, you can create the image loader to build a pattern, and you can pass in the component registry. And within that component registry, you can call add interceptor, and you can add as many as you want. Here we are adding only one. And the last thing that will be executed. So by default, like if you don't provide anything, like if you don't provide any interceptor, this will get executed, the engine interceptor, which is already part of library. So this is responsible for checking cache. Basically, it will check the in-memory cache of the library before passing things to mappers and other steps. So it's responsible for executing pipeline after interceptor or your own custom interceptor. So this will be the last interceptor that will get executed after in case you provide your own. And it will check, it will hit cache if the request, the request that you are executing, the result is already there in cache. It will simply return that result instead of passing things to the next step. If it's not present in the cache, it will just hand over things to mappers. Now mappers are nothing but allows you to add, the custom support for your own custom data types. So let's just see example. So let's say this is the item class that you have, and within that you have image URL. And you can tell library like whenever I pass, image item as a image source, you need to map this item to the image URL. So you need to override, mapper interface, and then you need to implement mapper interface and override map method. And then essentially what you do, you tell library, okay, if this is the object that you get as a image source, this is how you can, get the actual image source. So in this case, it's the image URL. And yeah, so once you have that, you just have to call ImageView.load, and you can directly pass in that item rather than writing item dot URL. So if you have a nested hierarchy, here it's very simple. But let's say if you have a nested hierarchy of object and your image is deep down the hierarchy, instead of writing a lot of item dot this dot this dot this and then finally URL, you can directly pass that object, and library will figure out how to get the actual image source. And again, you can plug in your custom mapper through component registry. So this is similar to what we saw previously for interceptor. So you can have as many as add call within component registry. So you can plug in your interceptor, you can plug in your mapper and decoder, fetcher, whatever you want. You just put inside the component registry block, and it will, library will handle everything that you provided. The next step would be fetcher. So fetcher, as I mentioned, it actually fetches your image from the source that you provide. So in case if it is custom, in case if it is your own image from the resource, I mean the drawable resource, it will just directly give you drawable. There's no need to decode whatever you have in your app. But if you are fetching image from the network or file system, it will just simply fetch it and convert it to buffer source. And library has built-in fetchers. So asset URL fetcher is responsible for fetching image from the your asset folder, and then content URI is responsible for, let's say if you are providing any content URI, it will query that content URI and give you that image. And file fetcher will be responsible for fetching file from file system, and HTTP would hit the remote server and get the image. And if you want to write your own custom fetcher, that is also possible. So you just have to inherit from the fetcher and override these three methods. The first method is handle, so handles, and it takes your image source as an input. So you have to decide, okay, if I'm getting this image source, will my fetcher would my fetcher will be able to handle this request or not? If not, you can simply return false. Otherwise, you can return true. The next thing is key, and the key is nothing but a unique key that will be used for in-memory caching. So based on the image source that you are getting, you just have to return the unique key for the request, and that will be used by library to cache and refer that image in future through key. And then the last method is fetch, which is suspending function. And this is where actual magic happens. Basically, you get the bitmap pool, you get the data, you get the size that you want to fetch, and the other metadata. So option is nothing but metadata about your image request, and you can implement your own fetcher and return fetch result. And again, this is how you plug in your own custom fetcher to component registry. And then finally, once result is ready, so in case it's not your local resource, it will pass in the buffered source to the decoder, and it converts buffered source to actual drawable, uh, which is nothing but decoding your image to the actual drawable. And library has built-in format support like JPEG, PNG, SVG, HIFs, GIFs, video frame, and WebP. But in case if you need to decode something which library doesn't support, you can always do that by inheriting decoder and implementing these two methods. So handles, again, it gives you buffered source and the MIME type, and you decide, okay, whether my decoder will be able to handle this or not. And based on that, you can return true or false. And then finally, the decode method, which will give you bitmap pool, buffer source size, and other options. And you can decode your result and return the decode result object. And again, this is how you plug in your own custom decoder. And finally, once drawable is ready, it will be given to transformation. And transformation modifies pixel data. So it will modify pixel data. So in case if you want to, apply filter or maybe the circle transformation or rounded corner transformation, you can easily do that in the transformation. And library has built-in transformation. So blur, circle crop, grayscale, and rounded corner are some of the transformation that library offers. But in case if you need custom transformation, again, it's possible. So you just have to inherit this and implement key and transform. And key is nothing but here the unique key for transformation that will be combined with the key that we saw in the fetcher. So in case if you are applying transformation, the key that will be used for in-memory caching would be the combined key of the transformation and the fetcher. And finally, transformation where actual transformation happens. So it gives you bitmap pool, your bitmap, actual bitmap and the size. And you have to spit out, the bitmap, the final bitmap after transformation. And again, this is how you plug in your own custom transformation through component registry. And finally, at the end, you'll get a image result. So image result is nothing but sealed class, and it could be success result or error result based on like if your entire pipeline is successfully executed, then it will spit out the success result. If there's anything wrong, it will give you error result. Also, I want to touch upon the threads, threading. So if you are loading image asynchronously, the first two steps would be executed on main thread, the interceptor and mapper. And the remaining three, fetcher, decoder, and transformation, would be executed on the worker thread. And finally, the transition, which is not part of pipeline, but it's an animation that in case if you need crossfade or some other animation after image is available, obviously that has to happen on main thread. So this is, keep one thing in mind, this is only applicable if you are loading image asynchronously. If you are loading image through coroutine or through execute function of the loader, image loader, it depends on the coroutine context that you are executing within. So just keep that in mind. And yeah, this is what I have to mention here when it comes to threading. Finally, I want to touch upon in-memory caching. So library already gives you functionality for disk caching through OKHTTP. So there's no point discussing that. You can refer OKHTTP disk caching, and you can go through that. But here today I want to discuss in-memory caching. So disk caching is nothing but, before I discuss this, disk caching is nothing but like, even if your app is not in the memory, it will be available. So it will store locally next time if you launch your app. And in-memory cache is nothing but the cache that resides in your RAM. So once you clear your app, it will go away. So when it comes to in-memory caching, there are two layers, the strong memory cache and the weak memory cache. Strong memory cache will hold the strong reference of your bitmap, and weak memory cache holds the weak reference of your bitmap. So once based on your strong memory cache size, once it is full and it decides, okay, this is the least recently used bitmap, I need to kick this out from the strong memory cache, it will move that to weak memory cache. So let's see like how it performs caching and everything. So as I mentioned, like engine interceptor is the last interceptor that will get executed. So before executing the entire pipeline, it will just check whether the incoming request is already there in the strong memory cache or not. If it is there, it will just simply return a result from the cache, and it will short circuit the entire image loading pipeline. If it is not there, it will just check whether it's there in the weak memory cache. And if it's there, it will just return that. It will short circuit your pipeline, and then if it is not there in the strong and weak, then it will just execute your entire pipeline. So going into a bit detail about strong memory cache. So it's backed by LRU cache, and you must be aware about the strategy of LRU caching. So the one which is least recently used would be eligible to for the removal if memory is full, like if the strong memory is full. So it is backed by LRU cache concept, and the size of this cache is computed dynamically. So when I say dynamically, that means like as we saw earlier while creating the image loader object, we can also specify, okay, this is the percentage I want the library to allocate for the in-memory cache, the percentage of the free memory. So if you pass in, let's say 0.25, it will allocate 25% of your free memory as a in-memory cache. And if you don't give anything, I think there's a default percentage that library consider for in-memory cache. So let's see how things will move from strong memory cache to weak memory cache. So let's say you request image 1. It's not there in the cache. Initially, both cache are empty. So it's not there in the strong memory cache. So it will just fetch the image, store it, and return the image. Next time you request another image, again, you'll check cache. It's not there. Store inside the cache and return the image. Then the next time again, it will load another image and then see if it's there in the cache. It's not there. It'll store and return that image. Now let's say cache is full now after storing the image. Now next time if you request image, the image 1 would be responsible for moving from strong memory cache to weak memory cache. So this is nothing but LRU concept, and this is how it manages memory in memory cache. Coming to weak memory cache, it's backed by hash map. So again, you must be aware about hash map. So it maintains key value pair of your key and the list of bitmaps. I'm not going into detail about weak memory cache. I think I can leave that, and basically I can request you to go through library and understand this concept as an exercise. And basically it periodically removes bitmap after every 10 set operation. So let's say while you're moving things from strong memory cache to weak memory cache, and on every set operation, it will just maintain one counter and will keep incrementing that counter. And once that counter reaches to 10, it clears out weak memory cache, the bitmap that you're not using. So yeah, this is all about caching, and this brings to the end of this talk. So to kind of summarize this talk, basically we saw first like what is coil, and then we saw like the why aspect of this library, like modern, easy, lightweight, and fast. And then we saw the API, how you can use API to load images. And then we saw the entire pipeline, and finally we talked about the in-memory caching. So yeah, I think this is all about coil, and these are the few resources that I've used to prepare for this talk. And the very first resource is like the documentation of library itself. Library has very nice documentation. While I was contributing to this library, first thing that I did was like I went through the entire documentation and understand it thoroughly. So perhaps this can help you. And the second one is the podcast. If you are a podcast person, like I would encourage you to tune into one of the Android Backstage podcast, where author of this library talked about all the details about library and upcoming features. It's very old though. It's not a recent one, so things might be outdated. I'm not sure. And the last one is the blog about comparison between Coil, Picasso, Glide. So perhaps this can help you to decide whether you want to move to Coil or not. And with that, thank you so much for your time and listening. Before we take questions, I want to plug in one thing. The CodeAid. CodeAid is nothing but the conference that couple of community folks, including me, are doing for good cause. It's a fundraising event, and we'll be covering ML, Android, Flutter, web security, iOS. So there'll be nice sessions on all these technologies, and also there'll be panel discussion. So I would urge everyone to donate for this good cause and be part of it. So these are the details, as you can see on your screen. We have a website called CodeAid.space. You can visit that for more info. And as I mentioned, like it's for the good cause, so donation link is also there. So please donate if you can. And we have Twitter handle as well. So follow us on Twitter for all the upcoming updates. So we have amazing speaker lineups. And I think we already announced few speakers. We'll be announcing the remaining ones soon. So stay tuned for that. And yeah, like I would encourage everyone to be part of this and donate if you can. And if you have any questions, just hit me on Twitter regarding CodeAid. So with that, thank you so much. And yeah, I'm happy to take any question if you have.
Awesome. I think we have a lot of questions, Sagar. We have around 21 questions. So to take them up, I think Chintan, can we have a run through of questions?
Yeah, sure. So yeah, Sagar, thank you for the session. It was really nice. And let's go through some questions by our participant. In case anyone has more question, they can visit the Slido link and put there, or maybe in case if you can't find the link, just put it in the chat section. We'll try to address that. So our first question is why to prefer Coil over Picasso or Glide?
Correct. That's a very good question. So as I mentioned, like if you have a code base which is like very old and everywhere you're using, Glide or Picasso, and if you are a Java user, then I think if these libraries are working for you, there's no need. But if you are planning to use Kotlin in your code base, and the fact that like Kotlin will be here and it's a future, so I think it's good to consider this library if you are a Kotlin user, because it has a lot of support for Kotlin. As we saw in the talk, it has nice API for Kotlin, and it has support for coroutines as well. And plus, it's a lightweight. That's a plus point compared to other libraries. So with less memory footprint, I would say you're getting a lot of features. So yeah, you should definitely consider Coil.
Yes, yeah, that's a valid answer. Yeah. Also, we get a lot of extension APIs as well in Coil, which maybe we can't get in Glide and that, I guess.
Correct.
Yeah. So our next question is, if you're using RxJava, what is your opinion of using Coil in Rxified way?
Well, I am not too sure on this because I don't know like how you can consume Coil if you're RxJava user. So yeah, I won't be able to answer this.
I think Sagar, maybe you can like wrap up some of the coils loaders with like some asynchronous stream using Rx, but under the hood it would still use like coroutines, right, Sagar?
Yeah. So under the hood, even if you're a Java user, it doesn't expose coroutines directly. Obviously, you can't call coroutines from Java. You can't launch or call suspend function, but under the hood, it uses coroutines. But yeah, I'm not too sure on this. If you're using Rx, is there any way to observe your image? Perhaps there must be library to handle this. Perhaps not. But yeah, not too sure on this.
Okay. So the next, let me go to next question. Then does Coil has
Thus, Coil has built-in support for built-in compose support. Okay, by planning to, I'm aware of Accompanist. Yeah, so Accompanist is the library. Besides that, I don't think so anything exists. And officially, also first-party support. I'm not sure whether that will be in pipeline or not. But yeah, Accompanist is something that you should definitely check if you are planning to use Coil within Compose.
Got it. So we have, so the next question is, I read Coil performs a number of optimizations, including memory and disk caching, downsampling, reusing bitmaps, etc. Glide also does that, right? Why is it fast?
Interesting. Yeah. So see, I'm not saying like Coil is fast compared to Glide. So perhaps the resource that I shared, the second one, the last one, wherein author of that blog compared each and every library. I think not each and every, Glide, Picasso, and Coil, the library. Yeah. So you can check that. I think Coil is lagging behind uh, uh, compared to Glide and Picasso. I'm not sure. That was like very old blog post, so I'm not sure right now what's the scenario. But yeah, like as I mentioned, like if Glide is working for you, I mean, there's no need to consider this library. If Glide is very fast for you, please continue, using Glide.
Got it. And also the blog post Sagar was mentioning about, you can find it in the chat if you are curious about reading more about the blog post Sagar mentioned. The next question
Cool.
we have is, does Coil have any plan to support KMP?
That's an interesting one. Unfortunately, yeah, even I'm not aware. So yeah, I can't answer this. Sorry.
Another one we have is, any drawbacks of using Coil?
Uh, Drawbacks. I don't see any drawbacks if you're using, even if you're a Java user, I don't see any drawbacks of using Coil. In fact, the fact that it's very lightweight, I don't see any drawback. But again, it's very subjective. This question is very subjective, so I'm not sure. Like, at least for me, I don't see any drawback of this library.
The next one we have is, how is the performance of Coil with respect to bitmap caching, etc.?
So I'm not clear on question. Like, what do you mean by performance? Again, like, if you're talking about, like, is there any like overhead here while caching or anything, then I think I don't see any like performance implication when it comes to caching, because you don't have to manage the caching, library manages for you. So as long as you're configuring the right way based on your requirement, I don't see any like performance implication while using Coil.
Got it. Maybe Chintan has reconnected, so maybe Chintan could try going over the next questions.
Yeah. So moving towards the next question. Like, will it be possible to write custom transformers?
Yes, definitely, it is possible. So yeah, so you can, as I mentioned in the talk, you can implement transformation interface, and basically you have to override two methods, the key and the actual transformation, and you can write your own transformation. So it gives you bitmap as an input, and you can modify the pixel data, and you can spit out the transformed bitmap. So yeah, it's possible.
Yeah. Okay. So when we use Picasso or Glide, we need to check if the URL string is not null, empty, correct, etc. Does Coil take care of this validation itself?
Yes. So basically, like, if you're using Java, then perhaps you have to manually check. Of course, I'm assuming there must be annotation. But if you're using Kotlin, then yeah, like, you have to pass data, which is nothing but image source, and it has to be non-null. So you get that validation if you're using Kotlin. And if you're using Java, perhaps I think there is a annotation. I'm not too sure on this. That will give you lint warning, like when you pass null data.
Okay. Yeah. So next question is, like, if an image is of high resolution and only want to load the image according to width and height of the image, how can I transform image before it's shown?
So if your image is high resolution, okay. So as far as I know, library will take care of this. Even if you're asking for the high resolution image, I think it'll downsample based on your width and height provided. So you don't have to worry about this.
Okay. Yeah. So how to load images and RecyclerView, that is list by keeping performance in mind, like image dimension, time, etc.
How to load images in RecyclerView, okay, by keeping performance in mind, like image time. Okay. Again, I'm not clear on the question itself, but
yeah, so maybe he's talking about, like, when we have high resolution images and like lot of images in RecyclerView. So while scrolling and you have to maintain the memory thing and dimension, like some images are kind of different width and height and some are different. So how can you?
Yeah, so like, as I mentioned, I think this is related to previous question. Then library takes care of downsampling and everything, so you don't have to worry about that. Besides that, if you're using RecyclerView, library also takes care of manually canceling the image request. So if you're like scrolling very fast, it takes care of canceling the old image requests. So you don't have to worry about that.
Okay. Yeah. So does Coil has built-in support for SVG? How Coil is handling the image when API can return JPG, PNG, and SVG file also? It is automatically identified SVG and loading.
So
Okay, so
Coil
maybe
has so Coil has support for SVG. So for that, you know, instead of depending on the Coil base library, you can depend on the Coil SVG, and that will give you SVG support as well as base. So yeah, Coil does has support for SVG, and based on the data that you're passing, I mean the image source that you're passing, it will automatically figure out whether it's PNG, SVG, and based on that, it will load. So you don't have to worry about that.
Okay. Okay. If I want to load like quite a lot of images, how do you think one should go about to use predictive fetching to load those with coils?
Okay. Yeah, so Coil has this thing called lazy loading or prefetching rather. So perhaps you can read the documentation. Again, I'm not clear on that. But Coil does give you that functionality wherein if you want to load image in advance, that is also possible through Coil.
Okay. Next question would be interesting for you. Like is BookMyShow using Coil?
Okay. No, we are not. We are using Picasso, and we recently integrated Glide as well. I think we'll be removing Picasso. That's the intention. But yeah, we are using Glide. And as I mentioned, like if you have, you know, very large code base and, you know, you have to take care of a lot of places where you're loading image. And BookMyShow is the image heavy app, right? And we are doing a lot of image loading in our code base. So for us, I think for now, Glide is working. So we'll be continuing using Glide. But it makes sense if you're starting something new, or if your app is very small and you know you're planning to use Kotlin. I think it's a nice opportunity to, you know, move to Coil.
Yeah, I think we lost Chintan, I guess, or is it me?
Yeah, I think all of us.
I think we lost him.
Awesome. We'll take up the next question, right? So, which is, does Coil support AVIF image format support? That was announced in Android 12.
This is a very good question. I think there must be issue open on GitHub. I'm not too sure, but I think this must be in the pipeline. Right now, it's not there, but I think in future it might come.
Okay, next one is, does Coil support animated GIFs or APNGs?
Coil does have support for GIFs. Animated PNGs, as of now, as far as I know, is not supported. But I think I saw one issue open on GitHub. So yeah, I think this must be in the pipeline. I'm not sure, but it has support for animated GIFs.
Right. So next one is, does Coil support native NDK image decoder, which is available from Android 11 and is now fully supported in Android 12?
This is also a very good question. Unfortunately, I don't know answer for this.
Yeah, I think the premise behind this was that like the Android team introduced the image decoder so that you could reduce size, because a lot of apps were bundling custom image decoders, if I'm not wrong.
Correct.
Yeah.
So there must be plan to use this going forward, but again, not sure on this.
Okay, next one is, can Coil be used with JetBrains Compose on desktop? Can it be used in headless mode?
Well, I have no clue about, you know, Compose on desktop. So yeah, sorry, I can't answer this as well. No clue.
Does Coil have both disk and in-memory cache?
Yes, it has both. Disk cache is through OKHTTP disk cache. So it depends on the OKHTTP for disk cache, and in-memory cache we already discussed in the talk.
Right. I think we'll take up the next 5 questions, 6 questions. So the next one was, I think we lost it. Which was, there was a specific question on, what do you like about the BookMyShow code base? And I know it was not specific to Coil. So I think we can pass on that one. Be enabled with Kotlin Lambda function in browser app, where Coil's parameters have to be populated for AI, ML image types. It's a big one.
Well, I'm not too sure on this as well. Yeah, sorry, I can't answer this as well.
Maybe Rishik, maybe you can put some.
Yeah.
If you can.
If Rishik can answer this, that would be great.
Oh, so for this one, I'm not sure what AIML image types mean in the first place. Because, yeah,
I think it's like AI ML generated images, maybe like.
Yeah, it could be that.
But if you are generating an image with AIML, you'll probably not use Coil in the first place. This is what I was thinking. So maybe Anshuman could better elaborate the question, if that would be possible. Then.
Okay, so we'll take up the last one, which is, I think, yeah. I have designed Android View in IntelliJ IDEA IDE with basic Kotlin Gradle or onCreateView function. How fetcher interface can allocate GCP CLI in a region? Wow.
That's a tricky one. Yeah, big. Sorry, I can't answer this as well.
A very nested question, big one. So okay,
Yep.
perhaps maybe like we can get back on Twitter, Sagar, and then like figure it out. And
Yeah, sure. Yeah. So yeah, I would love to answer whatever I can. So all the unanswered questions, like just send it to me. I'll try to find the right answer.
Hey, will the slides be available? Yes, definitely. We will share them on Twitter. Yep.
Yeah, slides will be available.
And can Coil unsample images for me? If yes, does it use something like nearest neighbor interpolation or something else? Somebody's been studying DSA, I think, but.
Yeah, this is interesting one. Again, not sure. Like, I'm sorry, like I'm skipping a lot of questions today, but yeah, like a lot of them are either not related to Android or maybe like my knowledge is not, in depth. So yeah, sorry about this.
Hey, the last one is Coil pure JVM library or only Android library?
It's an Android only. So it's an image loading library for Android. Because it has a lot of stuff which is Android related, so ImageView and all. But again, I'm not sure whether you can use this in JVM. Maybe like not too sure on this. Perhaps you can try because when it comes to asynchronously loading image, you can use coroutine and basically you can utilize result however you want. So just check. I think it will return you drawable, and like I'm not sure drawable whether you'll be able to use somewhere else, but yeah, not too sure on this. But my intuition is like you can't use Coil outside Android, or you can try.
Cool. I think that's been it. People are also thanking you on the Slido, and that's what we also want to do. Thanks, Sagar. It's a wonderful afternoon. We've talked a lot about Coil. Very specifically, you explained us how memory caching is done and how some of the benefits are for Coil. And we've also shared some great material as well, right? Also, the questions from our audiences today are like amazing. I must say that, right? Like, you've been a great audience. And with that being said, I think we will share stuff on Twitter, the links for the resources that Sagar has mentioned, the slides as well. And about CodeAid as well, like we are also participating with this CodeAid initiative that a lot of people in India have started. And they are doing an event on 26th and 26th June, which is in the upcoming week. So definitely check that out. And if you can contribute, please do, because it is going to directly be contributed to the COVID relief fund, right? So
Correct, yeah.
So with that being said, I think that's been it. And we have a lot of events coming up. We are expanding our team also. So thanks for joining today, and we will see you guys in the next one.